Is the Earth flat or is the Earth round? Here's some evidence from navigational techniques. And if you don't believe my conclusion, the navigational technique will still work to get yourself a fix when you're out in the ocean. How far can you see to the horizon? If you're standing on a boat which deck is pretty close to the water line, you're going to be about 5 or 6 feet above the water line, you can see the maximum distance of about 2.5 miles. Let's say you see a lighthouse in the distance. That 2.5 mile distance doesn't get further if you have more intensity. For instance, if you look through a pair of binoculars and you still can't see further than 2.5 miles to the horizon if you're looking at an object on the horizon. Now, let's say you're coming in from the ocean and you're looking at a lighthouse. What you can see is based on your height of eyes. And it also is based on the height of the object that you're looking at. If I'm looking at a lighthouse on the horizon, let's say that lighthouse is Cape Lookout Light and I'm coming in from the Atlantic Ocean. Cape Lookout Lighthouse is about 150 feet off the water. How far away does that lighthouse come into view? We use the geographic range table. Now there's a formula to figure that out. What you can use is distance equals 1.7 times the square root of the height of the object. If you don't want to do all that math, there's a guy named Nathaniel Bowditch who did all the calculations for you. You can go to one of his volumes on navigation, turn to the geographic range table, and all that's laid out for you right here. If I add the height of the lighthouse off the water plus the height of my eyes off the water, I can see that lighthouse from 20.6 miles away. So we call this dipping a light. As I'm approaching land, I know about the direction where the lighthouse is going to be. And so what I'll do is I'll stand on the deck of the boat, I'll look for the lighthouse. You can use binoculars, or if you can see it with your naked eye, that's fine. You're going to look for the lighthouse, and as soon as that lighthouse comes into view, I'll dip down about a foot, and the light will disappear over the horizon. I'll come up, and I can see the light. I'll go down, it disappears, and then I know that I'm exactly that 20.6 miles away from the lighthouse. So I take that distance, about 20.6 miles away from Cape Lookout Light, and it gives me the name of the lighthouse and how high it is off the water, and I measure from here 20.6 miles out. I draw an arc. Now I know I'm somewhere on that arc. Now I got to find out where I am on that arc. Now I'm going to take my hand-bearing compass. I'm going to aim it at that lighthouse, and I'm going to come up with a number or a degree that bearing is to the lighthouse. And let's say it's bearing about 330 degrees. I'm going to take my parallel rulers. I'm going to go to 330 degrees magnetic, which is the inner compass rose, put it on that lighthouse, and then I can draw a line out this way. I can extend that line to where it crosses where I first saw that light. I'll put a little dot with a circle around it, and that's my fix. So that's called dipping a light to find my location. I know exactly where I am at a certain point of time, and I can navigate correctly to shore. And here's that formula again. Here is a representation of what's going on. D1 is the distance between your boat and the horizon, and D2 is the distance between the horizon and that lighthouse. The only way this works is if the Earth is round or spherical. Again, you can use your binoculars or intense vision at the waterline. You can only see a certain distance no matter how high-powered your view is. Only way it works is if there's a curvature of the Earth and you're looking over the top of the horizon. This is one of the many reasons why sailors learned early on that the Earth was round.